Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at all you need to know about your engine crankshaft. Think of a crankshaft as the heart of the engine's conversion process. Its primary job is to take the linear up and down motion of this piston and then convert it to a rotational motion. Let's see it in action. For example, piston is moving up and down, piston is reciprocating. As you can see, that reciprocating motion is turned to a rotary motion exactly at the crankshaft. Now, this rotation is the ultimate thing that turns the transmission, the drive shaft, and finally, your vehicle. So, the vehicle will be driven as a result of the rotational motion generated by the crankshaft. Now, without a crankshaft, an engine would just be a collection of pistons, connecting rods, and other metal parts doing nothing. So they are useless. That is why we call the crankshaft is the backbone of your engine. When you look at the location of the crankshaft, it is usually located in the crankcase, in the engine block, in the crankcase. Upper part we have the cylinder, then followed by the engine block. So the crankshaft is to be embedded in the lower portion of the crankcase. And as you can see, it is connected to the connecting rod. That is how it receives engine power from the pistons. The crankshaft is precisely engineered component and it has several parts and several functions. Well, let's discuss about some of the parts. Right here, for example, you see this is the main journal. These are bearing surfaces that align with the engine block, and this is used to mount the crankshaft. So the crankshaft is to be mounted on the main bearing. There is a main bearing cap to be bolted onto the engine block. This is where the crankshaft is supported. This will allow the crankshaft to rotate smoothly within the engine block. For this particular engine, we have one main journal here, we have another main journal right here, and we have one at the front. And depending on the number of cylinders, we have crank pins, connecting rod journals or crank pins. These are offset. As you can see, right here we have the main journal. The main journal and the crank pin journals are offset. These are offset from the main journals and are where the connecting rods are attached. This is where connecting rods are to be connected. The offset is what creates the leverage for rotation. Whenever it is rotating, there is a leverage. That leverage is generated as a result of the offset. See this offset? There is an offset right here. You can see how offset it is from the center. That is the one that generates leverage when the crankshaft is rotating. And then on the crankshaft sides, we have webs. Right here we have crank webs or counterweights. These are thick, heavy sections that connect the main journal to the connecting rod, and they act as counterweights to balance. This crank pin is to be connected to the journal through this web or counterweight. These counterweights, they act as a counterweight to balance the rotating mass of the crankshaft. Whenever connecting rod and piston are moving up, the counterweight is moving in opposite direction, cancelling out any vibration as a result of unbalanced rotation. Unbalanced weight will be balanced by the action of the counterweights. This will prevent vibration that would be destructive. Had it not been balanced, locally balanced, the engine crankshaft will vibrate excessively and that might cause destruction. In order to prevent that, every time the crankshaft connecting rod is moving up, the counterweight is moving in opposite direction. Look, counterweight up, piston down. Piston up, counterweight is moving down. They are moving in opposite direction to make sure that the crankshaft is dynamically balanced. Somewhere in here, somewhere in between this web and the engine block, we have thrust washers. The thrust washers control the axial motion of the crankshaft. When braking and acceleration, vehicle parts, they tend to move forward when braking, move backward when acceleration. So this forward and backward longitudinal movement of the crankshaft within the engine block is controlled by thrust washers. For this particular engine, thrust washer will be installed in this gap. Right, there is a gap. It is to be installed in this gap that will control the longitudinal play of the crankshaft, or sometimes we call it the crankshaft end play. Crankshaft should not be playing excessively like this. Otherwise, if it is playing excessively, that can lead to bent connecting rod and engine damage. That is prevented by the thrust washers. And when you look at the other end, right here we have the front end. We call it the snout or front end of the crankshaft. This is the part that protrudes out. See right there, the crankshaft protrudes out, and then it will end up right in here. That is the protrusion, and it will be used to drive accessories. As you can see, accessories like the camshaft, water pump, all these are to be driven by the front end. It will have a timing belt or timing chain, water pump, alternator, AC compressors. All these are to be driven by this front end. And when you look at the back side, right there, the back side, there is a rear end or flange. This is where flywheel is attached. You see that black part? This right here is the flywheel. The flywheel is to be attached on the flange of the crankshaft. For automatic transmission, we will have flexi plates that is going to be attached. Then that will connect the engine to the transmission. Look, for example, right there, flywheel is connected to the flange. That is connected to the transmission. Now, how does it operate? How does the crankshaft operate? When there is combustion inside the cylinders, the air-fuel mixture that is compressed in here will be ignited, and that will force the piston down in a straight line motion. The explosion that is resulting during the power stroke inside the cylinder will force the piston and connecting rod straight down. That force will be transferred to the crankshaft through the connecting rod. Then the connecting rod is attached to an offset. You see, it is offsetted from the center. Because of this offset, it will have a rotational effect at the crankshaft. This downward force on the offset journal creates torque, which is a twisting force, causing the entire crankshaft to rotate. Look, for example, now, this crank pin is offset. It is moved to that direction. So forcing this down will make the crankshaft to rotate. Now, this distance, the distance from the center to the crank pin, will also determine leverage. Leverage is the distance from the center of the main journal to the center of the crank pin. And this distance is the lever arm that determines engine stroke and is key factor in engine displacement. Look when it is turning. See this distance? The distance between this center line, the center line of the main journal, and the center line of the crank pin. As you can see, there is some distance in between the two. This distance is called leverage. Let's bring it to maximum BDC position or TDC position and see. Look at this distance. Right here we have the center line for the crank pin. Right here we have the center line for the main journal. This gap is called leverage. This will determine the engine displacement. Engine stroke, the stroke is the distance from BDC to TDC as piston is moving up and down. That is to be determined by this distance. This distance will decide the stroke. Stroke is usually twice of this distance. So, when there is massive force on the piston, that will rotate, push the piston at high pressure. When there is explosion inside this combustion chamber at the end of a compression stroke, we will have power to be generated. That power will force the crankshaft to rotate, and the crankshaft have a massive flywheel attached to one end. Now, the rotational inertia of the heavy crankshaft and the flywheel combined with power from all the other cylinders will help push the piston up and down to do other compressions, other intakes, and other exhaust strokes. In a multi-cylinder engine, the crankshaft is designed so that the power stroke from different cylinder occur at different time. For example, for this 4-cylinder engine, we have a firing order by which cylinders are generating power. The arrangement of the crank pins is very crucial for the engine firing order. This design ensures the engine is running smoothly and in a balanced manner. For example, if power is generated in cylinder number 1, then it will be followed by power in cylinder number 3, then followed by 4, then comes to 2, 1, 3, 4, 2. This is the firing order for this particular engine, for example. Crankshafts are meticulously balanced both statically and dynamically. An unbalanced crankshaft can cause severe engine vibration, leading to premature wear and potential engine failure. This is where counterweights are very crucial. Counterweights, they locally balance. When this much mass is moving up, a comparable size mass is moving down, that will balance. And when two pistons are moving up for this 4-cylinder engine, when these two pistons are moving up, these two pistons cylinder moving down, this will entire balance of the crankshaft is maintained in such a fashion. Usually forged steel is used for manufacturing high performance and diesel engine crankshaft. Forging aligns the metal grain structure, creating strong and more durable crankshaft. On some, billet steel is used, machined from a single solid block of steel. This is the strongest and most expensive option, and it is reserved for the most extreme racing engines when it comes to crankshaft manufacturing. The crankshaft design directly determines the engine stroke, which is a key component in calculating engine displacement. As when we look at the manufacturing process of the engine crankshaft, there are different phases to be taken place. There is forging and casting, there is machining, there is heat treatment, and finally, the entire crankshaft has to be balanced. Now, what are some of the common crankshaft-related problems? Well, the first one is wear. Wear on the web journals. Over time, the main rod and the crank pin, they will wear down, leading to knocking sound and low oil pressure. When this wear out, gap will increase. That will leak lubricating oil, leading to low pressure. And the other wear is when the crankshaft starts to work. When the thrust bearings are worn out, crankshaft will start to play sideways. This is end play will increase. The crankshaft can move excessively forward and backward when braking and accelerating. The other common problem is crankshaft fracture. In extreme cases like over-reviving, a crankshaft can crack or it can snap. Usually it snaps in the place where the web is connected to the main journal, which is catastrophic for the engine. And the other common problem is bearing failure. There are bearing journals and bearings in here. There are bearing journals and bearing at the crank pin also. This main rod and the crank pin, they can spin, they can seize if the journals are often destroyed due to lack of lubrication. So these are some of the problems associated with the crankshaft. So when we finally summarize the key function of a crankshaft, it is converting the linear motion of the piston to rotary motion, and it is located in the engine block, and its primary component responsible for transferring engine power to the transmission. It will receive power from every piston and then transfer that to the flywheel, and the flywheel transfer it to the manual transmission. If it is automatic, it will be connected to a flexi plate. Its strength and balance are non-negotiable for engine longevity and performance. If it is out of balance, if some of the balance is thrown out, that will cause extreme vibration because it is operating at extreme speed. It is the engine's powerhouse and translator, turning explosive energy into usable mechanical work. That is why it is very crucial to keep your crankshaft in good shape. Always make sure that there is abundance of oil lubricating the crankshaft. Don't over-revive your engines. That will cause catastrophic engine failure. And normal driving can prolong crankshaft service life. Abnormal driving will shorten the service life of your crankshaft. Look how the crankshaft is converting the reciprocating motion of the piston to rotation. See? Now this is running in a very slow motion because this is used for demonstration, but in actual engines this is running in thousands per minute. 3,000, 4,000 revolutions per minute, running at extremely high speed. That is why it is very crucial that we have proper lubrication and oil flow. See, there are oil galleries and oil passage. Oil drilling is there. Look, there is an oil drilling, feeding oil. See that? That is the oil passage, feeding lubricating oil to the crank pin, receiving oil from the oil gallery. So that is very crucial. And it is responsible for driving all the accessories. Look, alternator is driven by it, camshaft is driven by it, water pump, cooling fan, all these are to be driven by the crankshaft. And on the rear side, transmission will be driven by the crankshaft. So that's why we say crankshaft is very critical and very crucial. So these are some of the things that you need to know when it comes to your engine crankshaft. Well, dear viewers, that is all we have for you regarding some of the key features and some of the key important points to be remembered when it comes to your engine crankshaft. If you liked this video and if you enjoyed what has been presented, please do smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.